Hello students, in the previous video we took the examples of power series expansion method, and we also discussed about how a power series expression is derived, and in this video we are discussing about transform analysis of LTI systems. Okay, now in that we first discuss about transfer function and impulse response. Now if you consider an LTI system having an impulse response, so just imagine this one. We have a system, LTI system, with impulse response h of n. Now the input to the system is x of n and the output for the system is y of n. So the output is given by y of n is equal to x of n convolved with h of n. Okay. Now if we take z transforms on both sides, taking z transform on both sides, so we get y of z is equal to x of z into h of z here. Now the system function is defined or is given by output by input. So h of z is equal to y of z divided by x of z, where this h of z is the z transform of impulse response h of n. X of z is the z transform of input x of n, and y of z is the z transform of output y of n. Now this is the transfer function or system function of the LTI system. So this is how we denote that h of z is equal to y of z by x of z. Okay, why? Because h of z is referred as a system function or transfer function of the system. Now based on this, we are going to take some example where a system will be given with input and output in the time domain system. Now we are supposed to find the impulse response of that. Now to find that impulse response, that means x of n and y of n will be given. We have to find h of n. We have to do the following step here. That means we have to take the z transform of x of n and y of n, and we have to express in the form of h of z is equal to y of z by x of z. Then we have to perform inverse z transform by either you can go for partial fraction expansion or power series, but usually we prefer partial fraction expansion. By using that, we can find the inverse z transform of the transfer function h of z, which gives us the impulse response h of n of the system. Let's take some example on this. Okay, so here is a problem. It's given that a causal system has input x of n and output y of n. Find the impulse response of the system if x of n is equal to delta n plus 1 by 4 delta n minus 1 minus 1 by 8 delta n minus 2, and y of n is equal to delta n minus 3 by 4 delta n minus 1. Now to solve this, you have to remember the basic or the standard Z transforms of the signals, like delta n, u of n, alpha n into u of n, minus alpha n, u of minus n minus 1, and etc. Now based on that, first, if you look at the data given is x of n and y of n is given, we have to find the impulse response of the system, that is h of n. Okay, so now first step, taking Z transform for x of n and y of n. The given x of n is equal to delta n plus 1 by 4 delta n minus 1 minus 1 by 8 delta n minus 2. Now if you take Z transform, you will get x of z, x of n, Z transform of x of n is x of z. Now Z transform of delta n is 1 plus delta n minus 1. It's a time shifted version of delta n. So if you remember, delta n minus k, its Z transform is z to the power of minus k. Now in place of k we have 1, so we'll get z to the power of minus 1. In the same way, minus 1 by 8 into z to the power of minus 2. So this is the Z transform of x of z. And y of n is given as delta n minus 3 by 4 delta n minus 1. Now if you take Z transform, y of z is equal to Z transform of delta n is 1 minus 3 by 4 delta n minus 1. So Z transform is z to the power of minus k. In place of k we have 1, so Z inverse. Now we found x of z and y of z. Okay, we have to express this in a transfer function. So how the transfer function is given by h of z is equal to y of z by x of z. Now y of z is 1 minus 3 by 4 z inverse, and x of z is 1 plus 1 by 4 z inverse minus 1 by 8 z to the power of minus 2. Now we have to find the factors for the denominator, which is minus 1 by 4 and plus 1 by 2. So 1 minus 3 by 4 z inverse divided by 1 minus 1 by 4 z inverse and 1 plus 1 by 2 z inverse. I am writing the factors directly here. Now we have h of z with the Z transform or the transfer function given by this. Now if you observe the denominator and the numerator, the order is 1 here, the order is 2 in the denominator. So that is m is equal to 1, m is equal to 1 and n is equal to 2. So therefore m is less than n. So we can apply partial fraction expansion to the transfer function. So by partial fraction expansion method, so we can write h of z is equal to k1 divided by 1 minus 1 by 4 z inverse plus k2 divided by 1 plus 1 by 2 z inverse. So how to find k1? K1 is equal to, so the denominator of that 1 minus 1 by 4 z inverse into h of z, where z takes the value of psi l, which is 1 by 4. Now if you substitute h of z, 1 minus 1 by 4 z inverse, and what is h of z? It is 1 minus 3 by 4 z inverse divided by 1 minus 1 by 4 z inverse into 1 plus 1 by 2 z inverse, where z takes the value 1 by 4. Now these two get cancelled. So you will remain with 1 minus 3 by 4 z inverse divided by 1 plus 1 by 2 z inverse, where z takes the value 1 by 4. Now if you substitute that, you will get 1 minus 3 by 4. We have z inverse, so 1 by 4 will become the inverse of it, that is 4, and 1 plus 1 by 2 into 4. So these two get cancelled and these two get cancelled. And we remain with 1 minus 3 divided by 1 plus 2 here. So that will give you minus 2 divided by 3. So 2 by 3 minus 2 by 3 is the value for k1. So k2, in other hand, 1 plus 1 by 2 z inverse into h of z, where z takes the value minus 1 by 2, because we have minus 1 by 2 in the place of psi. Now substituting that h of z here, 1 minus 3 by 4 z inverse divided by 1 minus 1 by 4 z inverse and 1 plus 1 by 2 z inverse, where z takes the value minus 1 by 2. So these two get cancelled. We remain with 1 minus 3 by 4 z inverse divided by 1 minus 1 by 4 z inverse, where z takes the value minus 1 by 2. Now substituting the value of z, 1 minus 3 by 4 into minus 2 divided by 1 minus 1 by 4 into minus 2. So 2 ones are 2 twos are, and again 2 ones are 2 twos are. So we will remain with minus into minus become plus 1 plus 3 by 2 divided by 1 minus 1 by 2. Now if you go further, it's 1 minus 3 by 2 and 1 plus 3 by 2. If you take the LCM 2 here, and this becomes 2 plus 3 divided by 2 here, and 2, this also 1 minus into minus become 2 plus 1 here. So we'll get 5 by 2 divided by 3 by 2, again 2 to get cancelled, so we'll remain with 5 by 3. So 5 by 3 is the value of k2. So therefore h of z is equal to minus 2 by 3 divided by 1 minus 1 by 4 z inverse plus 5 by 3 divided by 1 plus 1 by 2 z inverse. Now both, if you look at this, this is in the form of alpha n into u of n, where in place of alpha we have 1 by 4, and here this is alpha n into u of n, in place of alpha we have plus minus 1 by 2, and given the system is a causal system, so that means since system is causal, so if the system is causal, it means h of n is 0 for n less than 0. This is from the property of LTI system. So that means h of n is not present for negative values of n. It is present only for the positive values of n. So taking inverse Z transform on both sides. So h of z will give h of n is equal to, we have minus 2 by 3. So that value I am writing as it is, minus 2 by 3 into, now in place of alpha we have 1 by 4. 1 by 4 to the power of n into u of n, plus we have 5 by 3 into, in place of alpha we have minus 1 by 2, minus 1 by 2 to the power of n into u of n. So this is the impulse response of the system. Okay. Now we take one more example on this. So it is given that, so we want to design a causal discrete time LTI system with the property that if the input x of n is equal to 1 by 2 to the power of n into u of n minus 1 by 4 into 1 by 2 to the power of n minus 1 u of n minus 1, then the output is y of n is equal to 1 by 3 to the power of n into u of n. Now determine the impulse response h of n and the system function h of z of the system that satisfies this condition. So now looking at the problem, here we are to design a causal discrete time system, LTI system, given x of n and y of n, that is the system input and output. Now what we have to find here, we have to determine the impulse response h of n and the system function h of z of the system. So two things has to be done. So first we start with taking the z transform of input and output. Taking z transforms of input x of n and output y of n. So x of n is 1 by 2 to the power of n into u of n minus 1 by 4 into 1 by 2 to the power of n minus 1 u of n minus 1. Now for your information, I am just writing this 1 by 2 into u of n. If you take z transform for this, it will be 1 divided by 1 minus 1 by 2 z inverse. Now if you take the time shifted version of it, then it will be z to the power of minus 1 into x of z, that is 1 divided by 1 minus 1 by 2 z inverse. Okay. So based on this, So this is in the form of 1 by 2 n alpha into alpha n. So it will be 1 divided by 1 minus 1 by 2 z inverse minus, so this is 1 by 4 into z inverse 1 divided by 1 minus 1 by 2 z inverse. Now combining this, we can write that 1 by 1 minus 1 by 2 z inverse minus 1 by 4 z inverse divided by 1 minus 1 by 2 z inverse. Now both the denominator are same, so you can write that 1 minus 1 by 4 z inverse divided by 1 minus 1 by 2 z inverse. So this is x of z. So y of n is 1 by 3 n into u of n. So therefore we get y of z as 1 divided by 1 minus 1 by 3 z inverse. So the first one is transfer function or system function is given by h of z is equal to y of z by x of z. Now just substitute that y of z is 1 divided by 1 minus 1 by 3 z inverse, and x of z is 1 minus 1 by 4 z inverse divided by 1 minus 1 by 2 z inverse. Now if you simplify this, you will get h of z is equal to, so this denominator of the denominator goes to numerator. So we get 1 minus 1 by 3 z inverse into 1 minus 1 by 4 z inverse. Now this is the h of z. Now looking at the numerator and denominator, the order are m is equal to 1 and n is equal to 2, because if you multiply z inverse and z inverse, you will get z to the power of minus 2. So therefore m is less than n, so we can apply partial fraction expansion. From partial fraction expansion, so we can write h of z is equal to k1 divided by 1 minus 1 by 3 z inverse plus k2 divided by 1 minus 1 by 4 z inverse. So k1 is equal to 1 minus 1 by 3 z inverse into h of z, where z takes the value 1 by 3. So 1 minus 1 by 3 z inverse into 1 minus 1 by 2 z inverse divided by 1 minus 1 by 3 z inverse into 1 minus 1 by 4 z inverse, where z takes the value 1 by 3. These to get cancelled, so will remain with 1 minus 1 by 2 z inverse divided by 1 minus 1 by 4 z inverse, where z takes the value 1 by 3. Now if you substitute that, 1 minus 1 by 2 into 3 divided by 1 minus 1 by 4 into 3 here. So that will give you 1 minus 3 by 2 divided by 1 minus 3 by 4. If you take the LCM, 2 here, now this becomes 2 minus 3, and here it is 4, you will get 4 minus 3. So simplifying that, 2 minus 3 is minus 1 by 2. 4 minus 3 is 1 by 4. Yes. Now this 2 ones are 2 twos are 2 goes to numerator. That becomes minus 2. So K1 value is minus 2. So similarly K2 is equal to 1 minus 1 by 4 Z inverse into H of Z, where Z takes the value 1 by 4. So substituting that 1 minus 1 by 4 Z inverse, and H of Z is 1 minus 1 by 2 Z inverse divided by 1 minus 1 by 3 Z inverse into 1 minus 1 by 4 Z inverse, where Z takes the value 1 by 4. So these two get cancelled. So you will remain with 1 minus 1 by 2 Z inverse 1 minus 1 by 3 Z inverse, where Z takes the value 1 by 4. Now if you substitute that, 1 minus 1 by 2 into 4 divided by 1 minus 1 by 3 into 4. 2 ones are 2 twos are. So 1 minus 2 divided by 1 minus 4 by 3. If you take this LCM, you will get 1 minus 2 is minus 1. So that will leave you with minus 1 divided by 3 minus 4 is minus 1 by 3. Minus minus get cancelled. This will go to the numerator 3. So this is the value for K2. So therefore H of Z is equal to, so K1 value is minus 2 divided by 1 minus 1 by 3 Z inverse plus K2 value is 3, 1 minus 1 by 4 Z inverse. And taking inverse Z transform. And one more thing, the system is, we are designing a system, causal system. So that means H of n is 0 for n less than 0. Okay. So H of n is 0 for n less than 0. So if you take inverse Z transform, H of Z will become H of n, and minus 2 I have written. Now this is in the form of alpha n into u of n. In place of alpha we have 1 by 3. So 1 by 3 to the power of n into u of n plus 3 into 1 by 4 to the power of n into u of n. Okay. So this is the impulse response of the system. Coming to the next problem, here a system has impulse response. It is having impulse response. H of n is equal to 1 by 2 to the power of n into u of n. So the system has impulse response. Here, determine the input. Determine the input to the system if the output is given by y of n is equal to 1 by 3 into u of n plus 2 by 3 into minus 1 by 2 to the power of n into u of n. Okay. Now, if you look at the problem, here we have to determine the input to the system, that is x of n has to be found, and given data is h of n and y of n. So, impulse response is given and output of the system is given. So, we have to find x of n. Okay. So, we go with the same approach, taking z transform of y of n and h of n. So, y of n is given as 1 by 3 u of n plus 2 by 3 into minus 1 by 2 to the power of n into u of n. Now, if you take the inverse Z transform, so you'll get y of z. So, if you take z transform, you get y of z is equal to, so this is 1 by 3, and the z transform of u of n is 1 divided by 1 minus z inverse plus 2 by 3 as it is written. Now, this is in the form of alpha n into u of n. In place of alpha, we have minus 1 by 2. So, that will be 1 divided by 1 plus 1 by 2 z inverse. Now, combining this, you will get 1 by 3 divided by 1 minus z inverse plus 2 by 3 divided by 1 plus 1 by 2 z inverse. Okay. Now, similar way, h of n is given as 1 by 2 to the power of n into u of n. So, if you take z transform for that, h of z is equal to 1 divided by 1 minus 1 by 2 z inverse. Okay. So, the transfer function or system function of the system is given by h of z is equal to y of z by x of z. Since x of z, we have to find x of n, so we need x of z, and x of z is also not given here. So, if you re-alter this, you will get x of z is equal to y of z by h of z. Now, substituting these values of y of z and h of z, now y of z we have 1 by 3 divided by 1 minus z inverse plus 2 by 3 divided by 1 plus 1 by 2 z inverse whole divided by 1 plus, don't think plus minus here, 1 minus 1 by 2 z inverse. Now, in the numerator, you can see this. So, y of z is not in the simplified manner. So, you have to take the LCM and you have to bring it to the standard form or a most simplified version. Now, if you take the LCM and simplify the numerator, you will get this 1 minus 1 by 2 z inverse, and in the denominator you have 1 by 1 minus 2 z inverse. Okay, so now this numerator will go to the denominator is 1 minus 1 by 2 z inverse, and the numerator is 1 minus z inverse, and 1 plus 1 by 2 z inverse. So if it goes to the above, so you will have 1 minus 1 by 2 z inverse whole square, uh, and here one more thing, this thing, so this is 1 divided by 1 minus 1 by 2 z inverse. So that's my mistake here. So 1 divided by 1 minus 1 by 2 z inverse. So that will goes to the numerator, and in the denominator we will be having 1 minus z inverse and 1 plus 1 by 2 z inverse. Okay, so this is the expression for h of z. Now if you look at the numerator and the denominator, both m is equal to 2 and n is also equal to 2. So therefore m is not less than n. So we have to go for long division method. Now using long division method, so before that, this denominator we have to combine this as well as the numerator, because it's in the form of a minus b whole square. So we can write h of z as, since we have to apply the long division method, 1 minus z inverse plus 1 by 4 z to the power of minus 2 divided by 1 minus 1 by 2 z inverse minus 1 by 2 z to the power of minus 2. So that means we have multiplied the denominator, and in the numerator we have a minus b whole square form. So that's what we have expanded here. Now this long division method, we have to write the denominator in the decreasing order. So minus 1 by 2 z power minus 2 minus 1 by 2 z inverse plus 1, and the divisor is 1 by 4 z power minus 2 minus z inverse plus 1 here. Now we have to eliminate the first term. Both have z power minus 2, z power minus 2. Now we have 1 by 4 and minus 1 by 2. So we have to multiply that with minus 1 by 2. So that will give you 1 by 4 z to the power of minus 2 minus into minus become plus here, 1 by 20, 1 by 2 again, 1 by 4 z inverse minus 1 by 2. So this become minus, minus, this become plus. Now these two get cancelled. Minus z inverse and minus 1 by 4 z inverse. So you will get minus 5 by 4 z inverse, and these are plus 1 plus 1 by 2, that is 3 by 2. Now look at the first term, it is z power minus 2, and the remainder order is z power minus 1. So we don't need to go further, we can stop here itself. So now based on this, our h of z is equal to, first we write the quotient minus 1 by 2 plus then the remainder minus 5 by 4, or you can write in the standard form that is 3 by 2 minus 5 by 4 z inverse divided by the numerator 1 minus 1 by 2 z inverse minus 1 by 2 z power minus 2. Okay, so this, now we can apply the partial fraction for second term, or let to keep it simple, I'll just write the denominator. Here we have the factors already known, that is 1 minus z inverse and 1 plus 1 by 2 z inverse. So now using or applying partial fraction for the second term, so we call that as h1 of z, that is equal to 3 by 2 minus 5 by 4 z inverse divided by 1 minus z inverse and 1 plus 1 by 2 z inverse. So h1 of z is equal to k1 divided by 1 minus z inverse plus k2 divided by 1 plus 1 by 2 z inverse. So k1 is equal to 1 minus z inverse into h of z, where z takes the value 1 here. So 1 minus z inverse, so 3 by 2 minus 5 by 4 z inverse divided by 1 minus z inverse and 1 plus 1 by 2 z inverse, where z takes the value 1. So these two get cancelled. So we'll remain with 3 by 2 minus 5 by 4 z inverse divided by 1 plus 1 by 2 z inverse, where z is equal to 1. Now if you substitute the value, 3 by 2 minus 5 by 4 into 1 divided by 1 plus 1 by 2 into 1. So that gives you 3 by 2 here, 4 here, 6 minus 5, that is 1 by 4 divided by 3 by 2, 3 ones are 3 twos are. So you should get 1 by 6 as k1. Now k2 is equal to 1 plus 1 by 2 z inverse into h1 of z, where z takes the value minus 1 by 2. So 1 plus 1 by 2 z inverse 3 by 2 minus 5 by 4 z inverse divided by 1 minus z inverse and 1 plus 1 by 2 z inverse, where z takes the value minus 1 by 2. Now these two get cancelled. So remain with 3 by 2 minus 5 by 4 z inverse 1 minus z inverse, where z takes the value minus 1 by 2. If you substitute this value, 3 by 2 minus 5 by 4 into minus 2 divided by 1 minus of minus 2. So 2 2s are. So you'll remain with 3 by 2 plus 5 by 2 divided by 1 plus 2, that is 3, and here it is 3 plus 5 divided by 2, so that is 8 by 2 2 4s are 2 1s are, so 4 by 3, that is the value for K2. So therefore H1 of Z is equal to, first value is 1 by 6 by 1 minus Z inverse plus 4 by 3 divided by 1 plus 1 by 2 Z inverse. So therefore H of Z is equal to minus 1 by 2 plus 1 by 6 divided by 1 minus Z inverse plus 4 by 3 divided by 1 plus 1 by 2 Z inverse. Now this one, we left it here. You can call this as equation 1. So this one we have written this is minus 1 by 2, and the remaining part we took as H1 of Z. We applied partial fraction to that. Okay, and I think I have made a small mistake here. This one, so we are trying to find X of Z. I think I mentioned H of Z everywhere, so my mistake. This is X of Z, so that makes this as X of Z, and this one as X of Z, and this we should call it as X1 of Z, and here as well this one is X1 of Z, and same goes here, X1 of Z, and here as well. And finally this is X of Z here. So I'll check once again. Yes, everything has been corrected. Now taking inverse Z transform on both sides. So this is minus 1 by 2, the first term, so that we can write it as minus 1 by 2 into delta n, because the Z transform of delta n is 1, and here plus 1 by 6, and if you take 1 by 6, it is 1 divided by 1 minus Z inverse, that is the Z transform of U of n, and here plus 4 by 3 into minus 1 by 2 to the power of n into U of n. So this is the input for the system. So now in the same way, we can try some examples on your own, that is to find the transfer function and all. So given, so try this on your own. So the first one is find the transfer function and impulse response of the system described by the difference equation . Now this is expressed in difference equation, that means it will be in terms of y of n and x of n, so they won't give it separately. So you will okay. So this one, you have to take Z transform on both sides, and you have to find out the transfer function h of z and y of z. Now if you take Z transform for this, you will get y of z minus 1 by 2 z inverse into y of z, and here 2 into z inverse x of z. Okay. Now take this y of z common, you will get 1 divided by 1 minus 2 z inverse, and here 2 z inverse into x of z. So h of z is y of z by x of z. So that means you can just cross multiply this, you will get 2z inverse divided by 1 minus 1 by 2 z inverse. Now this is the transfer function, and the rest of the steps are easy. You have to just find the inverse of this to get the impulse response. Okay, so in the same way, try this one. Y of n minus 1 by 4 y of n minus 1 minus 3 by 8 y of n minus 2, that is equal to minus x of n plus 2 x of n minus 1. So this is the another example, and try these two on your own to get the solution for this. And here one more thing is given, and I'll take that example in the next video. Okay, so I think you have understood this method. If you have any queries, do reply or comment on this video. Thank you for your time.